So when we've done perfect squares, when we've done difference of two squares, you can normally look at the excuse me, the numbers involved, and you can see that they are a square plus a square, okay, or a square minus a square for a difference of two squares. This is cubes. So just by their very nature, cubes are a little bit harder for you to see straight away. This one should be fairly straightforward. 8x cubed plus 1. Question you ask yourself, well, is there a cube number at the front? Okay, 8 is a cube, it's 2 cubed. X cubed is obviously cubed, and then plus 1. Is that a cube number? What's the cube root of 1? 1. 1 times 1 times 1 is 1 cubed. So, yes, positive 1 is a cubed number. So, we now use the form that we've got up there, which is that one, sum of 2 cubes, and we would write it in that form. So, what I would probably do in this sort of situation is go, okay, what's A, what's B? Well, remember, this is in the form of A cubed plus B cubed. So what's A? Nope. And what is B? Okay, so what you do to do that is you find the cube root of A cubed. So you go, okay, what's the cube root of 8 is 2. Cube root of X cubed is X. Cool? Does that make a bit of sense? Like I said, it's not altogether perfectly easy when you first start doing it. Alright, next step. Yeah, you're chucking it into that form. Now, they've given you the form, and like I said, in your any assessment, you would be given a formula sheet that looks like that. Not quite that big. We'll do it in A4 rather than A3. And you will find that you have factorisation up here on the first page of it, up in the top right-hand corner, which actually has your difference of 2 squares, your sum of 2 cubes, and your difference of 2 cubes. Cool? So it's actually got it there. So as long as you recognise that it is the sum of 2 cubes, and you're able to find the cube root of A and cube root of B, cube root of A cubed, cube root of B cubed, so you know what A and B are, then you can just use that form to do it. Now, what's the form? Does anyone remember it off the top of their head? Anyone want to disagree with her? Because you've all read it. Okay, so now we just substitute it in. So what do we get? Okay, notice how I put the 2x in brackets. Everything in the brackets is squared, because remember, it is everything in the bracket that is squared. So what do you end up with your final answer? 2x plus 1. And that's why I put the 2x in the brackets. You substituted in the a, which is 2x. Brilliant. But you've got to remember it's a squared, not just the x squared. So you had to square the 2 as well. Hence the reason I substitute in brackets. That way I can make sure anything I have to do to what I'm substituting in, I do it to the whole thing, not just the last bit. Everyone happy with that? That's not too bad. Right, we've got one on the next page. We have 27a cubed minus 64b cubed. Now, one little thing I'd like to point out is that a, okay, you know how in the form that we've been given, the general form, we've got a cubed minus b cubed? Well, the trouble is they've put an a and a b in the question, which can lead to a little bit of confusion. So if I'm going, okay, this is a difference of 2 cubes, so I've got a cubed minus b cubed, right? And I want to look at it and I want to go, okay, well, the things I need to know is I need to know what A is and I need to know what B is. Now, this is where people might look at this and go, oh, a little confused. Isn't A just A? What I want you to remember is that if I rewrote that question, I could have rewritten this question as 27x cubed minus 64y cubed. Cool? And now I don't have an A and a B in it. When I say find the A and B, it makes a lot more sense to you. Okay? It's just something you've got to be aware of. The fact that we use A and B here, that could be anything. That could be apple and bus, apple and banana. It doesn't matter. Okay? Yeah, it's that whole thing in front of the cubed. It would be in this, because we're going to go and use this one here. So yeah, it will be 3a. So it's the cube root of that, which is 3a. And the other one is 4b. Yeah. But that it is something that catches people out because they're so used to seeing it. It happens with equations when you're dealing with like linear equation, you're dealing with ax plus b, y equals plus c equals 0. And people get the x's and y's in there and they get thrown because the pronumerals in the general form are the same as the pronumerals they've put in here. Yep. Absolutely. This is exactly the same question. Yeah? The only thing I'd say is make it obvious that you've done that. Okay? Just sort of down here, write it, or write it next to it in brackets, and even right after it, so I don't get confused. I mean, no one's going to be upset with that because you obviously knew what you were doing. You just didn't want to let the minutiae, like the fact that they used an A and you're used to seeing an A in the general form, you didn't want to let that confuse you. Okay? That's actually showing more understanding than someone who almost gets it right but screws up because they got confused. And you've shown that you understand that. So, all right, so we've got those. So now what do we got to do? What's the expanded form again? For this particular one, this being a difference of? What is it? A minus B? Want the whole, just the general form. What I like to do with these is I like to write down the formula, write down what I know, substitute in, solve. Now, I've actually written down what I know before I've written down the formula, but when we're doing equations, this is honestly the safest way to do it because it always works. So what do we got? A minus B? A squared? Yeah. Excellent. Now, just before we move on, I want you to have a look at our values for A and B and double check that you are right. Yeah? Okay, just wanted to double check. It's just something. Because when you've got a negative in there, you've got to start thinking, is this correct? Yeah, it is. But I just want you to look at it and think about it. Okay? Always double check yourself. All right, so now what do we do? Substitute in. So what do we got? Yeah. What bit? That is the form. That's this one. The bottom of the 3. That's the second of those forms. It's on the previous page.
I don't remember what the question is. You always got that.
Well, if it is a difference of 2 cubes, yes. The previous question we did was a sum of 2 cubes. And the difference is literally that. Yeah, let's do it like that. 3a squared. I would, because it's an extra step at the moment, but it's a step that confirms that you've substituted in the correct thing. When you're substituting in a negative number, it's really important that you've got that so you don't get confused as to whether it's 2 negatives or whatever. 3a, 4b squared. Okay? So everything I've substituted in, apart from the left-hand bracket, which was just straight subbing in, everything I've substituted in the right-hand one is in brackets. Cool? 3a minus 4b. 3a squared, or 3a all squared is 9a squared plus 12ab plus 16b squared. Everyone happy with that? Sorry, mate? Yeah. Where? That is a 9. You can tell because I don't do my 4s that way. That's one of the reasons I do my 4s the other way. Because my writing is hideous.